Okay, so like if you ever spilled your coffee, right?
Yeah.
And you're like, why me?
Yeah.
Or like waiting for a friend and their flight is delayed and it's always that airline. You're thinking, why is this airline always the worst? It's like we're always looking for those why answers, those reasons for everything.
Yeah.
And that craving, it's kind of like what today's deep dive is all about, the principle of sufficient reason.
And what's so fascinating about this principle, this PSR, is like it takes that need for a why and it just pushes it to its absolute limit. It's saying everything that happens, the smallest particle, the entire universe, everything, it all needs a reason to exist.
And to help us wrap our heads around this, who better to kind of walk us through it than a physicist?
Yeah,
Right?
okay.
We're going to be diving into excerpts from theoretical physicists, Sean Carroll's paper, Physics and the Principle of Sufficient Reason, looking at this big philosophical question, this why question, but through the lens of actual science.
Yeah.
But don't worry, we're not going to like suddenly hit you with a pop quiz on quantum mechanics.
No, no quizzes, but our aim here isn't really to arrive at some kind of final, definite answer, but more to explore this really interesting intersection between physics and, well, philosophy.
Right, and trust me, you will come away from this with plenty to think about.
Absolutely.
Okay, so to kick things off, our brains, they seem naturally drawn to this whole idea of cause and effect, right? Like this past event led to this present event. It just makes sense. It's tidy. It feels like the past explains the present.
It does, doesn't it? But this is where physics throws in, well, a little bit of a curveball, you could say. So let's just take a look at classical physics for a second. Those laws of motion that Newton came up with, they function just as well in reverse as they do going forward. In other words, they are time reversible.
Time reversible. Okay, got to break that down a bit for me.
Okay, so picture this. You're watching a video of billiard balls, colliding on a table. Now, Newton's laws, they apply whether you play that video forwards or backwards. Which means the laws themselves, they don't really care whether the past is causing the future or if the future, in a way, is causing the past. It's kind of a trippy
Well,
thought,
it's
right?
like those laws of physics aren't too concerned with us humans and how we see time moving forward, huh?
That's it, precisely. And this is what really throws a wrench into that neat and tidy picture, that the past is the reason for everything we're seeing in the present. But if that wasn't enough, let's toss in another fun element, quantum mechanics.
Oh boy. Okay, so classical physics is already kind of shaking things up, but now we're talking
Mhm.
quantum mechanics. This is where it gets really interesting.
Yeah, so quantum mechanics, it's basically the rule book for how things behave at the subatomic level. And one of the most mind-boggling aspects of it is something called quantum measurement.
Okay, I always love a good visual. Can you walk me through it?
Sure. Imagine you have a coin and you're flipping it in the air.
Right, spinning.
You don't know if it's heads or tails until it lands, until you actually measure it, correct?
Makes sense.
Now imagine, in the quantum world, it's like that coin is both heads and tails at the same time, simultaneously, until the very act of measuring it forces it to pick a side. And as far as we know, that choice, totally random.
Hold on. So instead of a clear cause leading to a specific effect, we're saying at the quantum level, it's all kind of about probabilities.
Yeah, pretty much. And that throws a pretty big wrench into the whole past equals reason idea. Now, there are interpretations of quantum mechanics that try to salvage that determinism, but even those have elements that, from our perspective as observers within the universe, we just can't see. They're hidden.
Okay, so let me get this straight.
Mm.
Even the most fundamental laws of physics, they might not operate as straightforwardly as, cause and effect, at least not on a human scale. So does it even matter? You know what I mean? Like my reason for being late today, probably traffic. Even if, at the same time, the universe is off doing its own thing, its own cosmic reasons or whatever.
That is such a good point, and it really gets at the core of this thing called emergence. Think of it this way. Traffic, right? It's this incredibly complex dance of all these cars, traffic lights, pedestrians. But at some level, it's all like physics.
Right.
But we don't need to know the exact momentum of every single molecule in every car to understand why we might be stuck behind that one person who just can't find their parking ticket.
Oh, I feel that. Such a good analogy. So it's like there are different levels of explanation depending on what it is you're actually trying to understand, right?
Yeah. Like my frustration at being late, it's totally valid, even if the universe has its own grand plan, humming along to its physics-driven symphony, oblivious to my very real pain.
Exactly. So Does it even matter if the universe's reasons, if you even want to call them that, are different from the reasons we're worried about in our everyday lives?
Right, right.
That's something I want you to keep in mind, as we continue on with this deep dive.
My mind is already blown. But okay, let's say we can, like, kind of accept that for now, at least. There's still this giant elephant in the room. Why these specific laws of physics? Why is it these particular rules the universe seems to be playing by? Why not some other set? Good question. That's where the principle of sufficient reason gets even trickier. Even physicists, in their work, trying to discover these elegant, inevitable laws, they still have to make certain assumptions at the start.
So it's like they're saying, okay, assuming that reality works this way, and then building their theories on top of that assumption.
Exactly. But those initial assumptions, even if they're completely logical, they're still assumptions. There could be universes out there with totally different principles. What if instead of a quantum universe, it was a purely classical one? Or imagine different dimensions. There's a whole lot of what ifs out there.
So what you're saying is we haven't stumbled across, like, this ultimate cosmic rulebook. One that dictates our universe has to be this specific universe, right?
Right. It's like, not yet at least. There is this idea, though, called the anthropic principle. And this basically suggests, hey, maybe the universe's laws are the way they are because, well, if they weren't this way, we wouldn't be here to observe them. We wouldn't exist.
So it's like saying that the reason it rains is so plants can grow.
Yeah,
It's like you notice there's a connection there, but it doesn't get at that root cause, that why.
exactly. It's definitely something to think about, but it doesn't really scratch that itch for a more complete explanation.
Which leads us to the biggest why of them all. Why is there something instead of nothing? Why this universe, with its low entropy Big Bang and, well, everything in it, why did it even happen in the first place?
Ugh, the ultimate question. It's the biggest mystery there is. There have been many attempts to address it. Some physicists, like Boltzmann, they imagined an eternal universe where random fluctuations over a really long time, they eventually lead to universes of all sorts, including ours.
So you're saying our universe is, what, just this random
Yeah.
blip in, like, the grand scheme of eternity?
Yeah, in a way. But that idea, it doesn't really address why our universe seems so incredibly fine-tuned for life to emerge. It's like winning the lottery without even buying a ticket. It's possible, but the odds are,
Yeah.
well,
Astronomical, to say the least.
exactly. And then there's the idea that the initial conditions of our universe, maybe they were just simpler, which would make them more likely, more probable. But that, of course, depends on what you even mean by simple.
It's like that old joke that a messy desk is actually organized chaos, right?
Technically, I guess it's possible, but not very convincing.
Exactly. And this is where Carroll, he brings up this thought-provoking idea. He writes, and I'm quoting here, "It seems more defensible, at least given our current state of understanding, to admit that the existence of the universe is not something for which there is going to be a reason why."
Wait, so hold on. You're telling me we're supposed to just accept that some things, maybe even the biggest, most fundamental whys, just are?
Not necessarily. And this is important. Carroll, he's not saying we need to stop trying to understand, to stop searching. He's actually suggesting a bit of a shift in perspective. Maybe instead of searching for a why that fits into how we think things should be, we should focus on uncovering the what instead.
The what being, like the true nature of how things actually are, even if it means letting go of this deep need we have for everything to have a reason, at least in the way we traditionally think about it.
Yeah, that's a good way to put it. And to do that, we have to be careful not to mix up frameworks with the models we build within them. Like classical mechanics, quantum mechanics, they're different frameworks for understanding the universe. And within each framework, we build specific models to try to explain what we observe. Maybe finding a reason why is more about refining those models, our understanding of how the universe works within a given framework, rather than trying to find some ultimate explanation that's completely outside it.
Okay, so we've gone from cause and effect, this comfortable idea, to potentially having to accept that the universe itself might be the best example of something that just dot is. So it's a lot.
It really is. But remember, accepting the possibility of what we're calling brute facts, these parts of reality that might not have a simple, neat because attached to them, that doesn't mean we surrender to ignorance. It means we can focus our energy on figuring out what is instead of forcing a why onto things that might not have one.
Wow, okay, so what does all this mean for us, the eternally curious, the ones always asking why? That's something we'll be diving into right after we take a moment to hear from our sponsors. Don't go away. Welcome back to the Deep Dive. So before we went to those messages, we were kind of grappling with some pretty big, kind of mind-blowing ideas about like cause and effect and what even is quantum mechanics and like, does everything really need to have a reason to exist in the first place?
Yeah. And, we were discussing how physicist Sean Carroll, he suggests that maybe being okay with these brute facts doesn't mean we stop trying to understand.
Right.
In fact, it could actually be the key to understanding even more.
Okay, so let's say, just for a moment, we're open to this whole brute facts thing.
Mhm.
How do we even begin to understand something if we're not trying to find a reason, a why, for it to even exist?
That is the question, isn't it? And that's where things get really, really interesting. It's less about thinking in terms of why and more about thinking what if.
Okay.
What if instead of looking for one single ultimate explanation, we entertain the possibility that there might be multiple ways of looking at it, multiple frameworks for understanding the universe?
Multiple frameworks. Okay, I need an example. Give me an example. I need to visualize this.
Okay. So imagine you're trying to build this like crazy detailed model of a car. Like you're recreating every single piece, right?
Yeah.
Every nut and bolt, every wire perfectly. But let's say you never actually stop to ask why those parts are shaped the way they are or why they're put together in that particular arrangement.
You'd have, like, a technically impressive model for sure, but you wouldn't really get it, would you? Like, you wouldn't understand the engineering, the design choices, even the basic idea of why a car is a car.
Exactly. And that's what we might be doing if we cling too tightly to this principle of sufficient reason. We might miss out on discovering these underlying principles, these beautiful, elegant frameworks that govern how things operate, simply because we're fixated on needing a prepackaged reason why for every single detail.
Okay, so where do we even go from here? If some things, even like the universe itself, might just be, how are we supposed to wrap our heads around that?
That's the exciting part. It's about being okay with the unknown, not just asking why, but asking what if?
Yeah.
What if our universe is just one of many universes out there? A multiverse with a whole bunch of different universes, each with their own unique laws of physics. What if the laws that we observe here in our universe, what if they're just these emergent properties coming from something much deeper, something more fundamental that we haven't even begun to imagine yet?
So it's like, instead of looking for concrete answers like we're solving some kind of puzzle, we're being asked to question like the very nature of the questions themselves.
Yeah, exactly. And that's what real scientific inquiry is all about, right? To constantly be questioning, to be exploring, to push the boundaries of everything we think we know.
It's like we're explorers, right?
Yeah.
Standing at the edge of some undiscovered country. And that principle of sufficient reason, it was our map. Comfortable, sure, but also probably limited us. Now we're being challenged to set sail without it, to embrace the unknown and all the mysteries it holds, without needing a predetermined destination.
And who knows what incredible things we might find on that journey. New laws of physics, maybe. Completely new ways of understanding how the universe works. Heck, maybe even new ways of thinking about ourselves and our place in it all.
This is, wow, okay. This is a lot to process. Welcome back to the deep dive. Today we've really been going deep, haven't we? Like to the very edge of what we know about, well, knowing. We started out with this very human need to ask why about, well, everything. And we've seen how modern physics, especially these ideas from Sean Carroll, they kind of challenge us to rethink that impulse a bit.
It really has been a journey, hasn't it?
Right.
We started off with cause and effect, something we're all familiar with, took a little trip through the mind-bending world of quantum mechanics, and ended up questioning the very existence of, well, everything, the universe itself.
And this whole time we've been talking about these brute facts, those aspects of reality that just don't seem to fit into our need for a nice, neat reason why.
And what's interesting, I think, is that accepting the possibility of these brute facts, it doesn't mean we just give up on understanding. We're not throwing in the towel, right? It's more like we're trading in a very specific map, maybe one that wasn't quite right to begin with, and instead picking up a compass and, most importantly, that thirst for exploration, for venturing out into the unknown.
So instead of looking for just one answer, a single final answer to why is there something rather than nothing, which, who knows, maybe that kind of answer just doesn't even exist within our current way of thinking. What if we start asking, what if?
What if, exactly, what if this universe, our universe, with its own, like, seemingly random laws and these very specific numbers that govern everything, what if it's just one of many universes?
Mm-hmm.
A whole multiverse of possibilities, right? What if the laws that we observe here in our little corner of existence, what if they're not really random at all? What if they're just these emergent properties that come from something much deeper, something so fundamental that we haven't even begun to grasp it yet?
I like that. So it's like instead of trying to be detectives, right, trying to solve a case and find the one culprit, we need to become more like, well, explorers, setting sail without knowing exactly where we'll end up, ready for whatever wonders and mysteries we might encounter along the way.
And that's what true scientific inquiry is, right? Being open to uncertainty, venturing into the unknown, and being okay with not always having those easy, ready-made answers.
Beautifully put. So as we wrap up this deep dive, here's a little something to think about. Next time you find yourself asking why about something, and let's be honest, we all do it. Take a second. Consider the what and the what if too. What if these brute facts, instead of being roadblocks to knowledge, are actually doorways? Doorways to even bigger, more awe-inspiring mysteries, just waiting to be explored.
Keep asking those big questions. Never stop being curious. But remember, sometimes the most amazing discoveries, they come when we let go of needing certainty and embrace the excitement of the unknown.
That's it for this deep dive into the principle of sufficient reason. We'll catch you next time on The Deep Dive.